All right, here we are with our template for the chi-squared test of association, also recognized as the test of independence or homogeneity. So they're all synonyms for the same basic thing. It just depends on how you're writing your hypothesis. In demonstrating this, as you would need to use it for your independently chosen statistical test assignment, you basically use this if you've chosen to do categorical data. In the example I'm going to work with you here, I'm pulling data that I collected with an experiment in my in-class or my in-person class. And so our categories were based upon the courtyard. In this diagram, you can see where I have indicated the south side, which is where the sunlight's coming from, the north side, approximate measurements of 15 meters wide, top to bottom here in other words, and 60 meters long from south to north. The areas shaded in red represent the areas actually in the shade, in part because of the building to the south that is blocking the sun, and in part because of existing trees, particularly on the south side. This picture is older than the current status of the courtyard, as the trees on the north side were all cut down. So the only shade we have there is due to the building protruding into the courtyard. So using this basic setup, our first category centered around the idea if something was in the sun or if something was in the shade. It's categorical because we don't have a number to give that. I can't say that, oh, the sun equals 73.2 and the shade represents 54 point whatever. All right, I mean, there's ways you probably could do that, but that's not our objective here. Our second category then has to talk about what is it that we're interested in. If I was doing this as a t-test, I would do something such as what's the impact of sunlight on the length of the grass? In this case, I don't want to do measurements for the t-test. I want to do a chi-square test, which means I need categorical data. So my second category is going to be ground cover. And having observed the courtyard, we recognize there's several things out there. There are areas of grass and weeds, essentially vascular plants, and there are areas with moss. And so that lets us set up a question about, is the relationship between the sun exposure, or lack thereof, and the type of plants that can grow? In order to do that, we're going to have to collect data. In class, we use these little mini quadrant tools, which are ways to isolate the samples. While they can technically be of any size, ours for class are only 3 inches by 3 inches. We split into groups of 2 in our classes, and then each group had to take their quadrat and throw it twice in shady areas and characterize the ground cover, and then throw it twice in sunny areas and characterize the ground cover. In period 2, because we had a little bit of extra time, they did 3 throws in each zone. And then we collected this observational data in class. Now that we have that data, we can go back to our spreadsheet and fill things in. As always, we want to get in the habit of labeling things. So we're going to put in our name. I'm just going to go by Ream Demo here. Whatever the date happens to be, that should be in the form of month, month, day, day, year, 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 year. Period, whatever that is, 1, 2, 3, 4. If you're in the online, just put in CVOA. And then lab title or this analysis title, whatever it is your question that you're focusing on, maybe it's the assignment number. I'm going to put in here ground cover versus light. We always want to have labels and documentation so you have some idea of what's going on. Now, with the t-test, we focus on the research hypothesis and the null hypothesis, and typically with the chi-squared test, you only care about the null hypothesis. And the null hypothesis is generally to say that there is no difference, which basically means everything's homogeneous. I'm going to change this up, and I'm going to put in my research hypothesis. And what they came up with in class was that they thought they saw a difference, so let's see if in fact there is. So a research hypothesis is that sun gets grasses and shade gets mosses. And I want to put a comma in there, not an exclamation point. So, much like the t-test or any statistical test, if we can reject the null hypothesis, then what's left standing is the research hypothesis, and we can say that we've supported it. We're going to use our standard level significance here of 0.05. A simple way of saying that is that we're okay with a 5% chance that we are wrong in our conclusions. In other words, that we're wrong to accidentally reject the null hypothesis when we shouldn't. And now, just like the t-test, I have to start populating my data. If we did a goodness of fit, we already have expectations. We have that in the spreadsheet. It's another tab. I'm not worried about that. That one's pretty straightforward. It works a lot like the t-test calculator. It's pretty easy. But in these things, we're trying to see if things in nature that there's not a set expectation for, if they match or don't match expectations, we need to be able to figure out our observed values, from that our expected values, and then do the chi-squared calculation. This chart allows us to have a 6-category versus a 5-category analysis. It doesn't matter which axis gets which. I'm going to choose to put across the top here my light categories, sun versus shade, and I'm going to choose to put in my vertical one here the plant matter for ground cover. So grasses, potentially both if it has moss and grasses, and then just mosses. My data for this, going back to my other file where I have that written out, 27 sun grasses, 19 shade grasses. Three with moss, 11, 3 in the sun, 11 in the shade for mosses. And then for the both, 12 and 8. Now, if we watch our SciShow video, they go over how to set up these expected tables, and it's not super challenging, but it is a bit difficult to keep straight, especially the larger data set gets. We'd take the row total, which is going across, so over here, that would be looking at the 46, divide by the grand total, which is 80, times the column total, which is 42, and that's what's going to give me my different values here. So that's how that process is populated. It's automatically done in here, so you don't have to worry about setting up on your own. Now we have an expected table and our observation table there in yellow. We can get over to the chi-squared calculation. Again, the point of the tool is to keep things easier for you. We're letting the tool do the work for us, so we don't have to do it all. We have to design the experiment. We have to interpret the results. We don't have to do the computations. The machine can do that. We need the human brain for better things. It gives me my calculated value here of a 6.579. And you'll see now that that comes over here to this yellow box to show me the same thing. Now I've got to figure out my degrees of freedom. The degrees of freedom is based upon the rows. I have used 3 rows, and I have used 2 columns. All right, my data set is 2 wide, that's columns, and 3 deep, that is rows. That means my degree of freedom is 2. And now I need to come up and figure out what my critical value is, what my comparison value happens to be. Using my level significance of 0.05, my degrees of freedom of 2, I've got to find this table value. So I'm going to open up that link. I'm looking at my 0.05 column over here, and I'm going to come down to 2 degrees of freedom, which is a comparison value of 5.99. I get to plug that into my sheet here, 5.99. And what we care about right now is that this box stayed true. This is my calculated value, the 6.58. This is the critical value, table value, 5.99. My calculated value exceeds that. So the statement is true that my calculated value is equal to or greater than 5.99. Therefore, I get to reject the null hypothesis. That means that this box in red, in fact, is not true. All right, we've eliminated that as a possibility. So what's left standing? The fact that there is a difference between the plant cover in the sun and the shade. So that's how we use the chi-squared table for categorical data. Hopefully that helps get you through the tool.